hear you. I said, are you ready?
Hello everyone, Adam here again, back at Rocky Mountain RepRap Festival 2024. And this time I'm at the Hueforge booth with Steve.
Hey.
Hi Steve, how are you?
I'm good, how you doing?
Nice to see you. So, Hueforge, what's like the latest updates? What do we need to know?
So the biggest thing came out with Hueforge recently is the 7.1 build. We've added a lot more color aware options. So Hueforge lets you blend your filament, and it's hard to do the colors, multiple colors, and I've been working on making colors a lot easier, and that's what I'm focusing on right now.
So originally Hueforge was kind of based on the like how dark the colors are between like white and black, and you can kind of fit into the layers.
That's right, yeah, it was all luminance based before.
Luminance based, yeah. Whereas now you've got more color integration.
Yeah, so there's color pop and then there's color aware. And the big thing about color aware was it separates it into 3 Hueforges, but it was hard to tell where they were. You had to kind of work it out by feel.
Yep.
So I've now changed it so that now you can work it out. It's drawn on the screen for you. It makes it a lot easier to start working in those multicolor spaces.
Okay, cool. So should we take a look at some? Do you want to show me some of the examples that you have?
Sure.
Of the differences between the earlier versions and now?
Sure. So on the right here, we have one that's color pop. So the lower part of it, you can see on the side here, the lower part of it is the grayscale, and then the upper part of it is the color. And so here we're using a pink red to do the color. It's 4 colors on the top and 3 colors on the bottom. And then this one here is an example of color aware, where we have the red, the green, and the blue that are separated out. And I know this doesn't look red, but browns are considered red by Hueforge. And so that lets us do the layered look and hit the different colors and isolate them. So that's a lot easier now than it used to be. So the other thing I'm announcing here at Rocky Mountain is color match. Color match is still in very early alpha. I only have a couple of testers working on it. But what it does is it flips the script on Hueforge. Instead of having the mesh then help you define where the colors go, you move the colors and the mesh adjusts itself to match where the colors are.
Okay.
So that makes it easier. There's still some technique involved. It makes it easier to be able to do lots of colors and stack them together.
So there's still a kind of skill level in order to get the very best from it?
There's definitely, yeah.
We're kind of increasing performance and capability.
Correct.
With each sort of color-based implementation.
Yep, exactly. And one of the big things is with the color aware and color pop, there's this step where you go from one range to the next, and you can get these vertical artifacts that make it hard to make a coherent picture. I mean, if you with color match, if you do it well, you can shrink that right back down and get it down to, real thin, 1.5 millimeters, 1.5 millimeters, so that you don't get those steps.
Okay, cool. So, right, let's have a look at a couple of examples, I think.
Yep. All right, so here's an example of, this is a color aware as well, but you see that the lines here are raised, and if you tilt this at an angle, it gets a little bit out of whack and it's hard to see what it is. And the color match on this side, there's a lot more colors and they're all really tightly packed, so you don't have any issues with heights that you don't want to deal with. You can see up the side here again, there's so many more colors and it's all more of a continuous theme of color, whereas here you definitely have your ranges with the whites at the top and the blacks at the bottom.
Before we move on to the next booth, here's a number of Hueforge prints that were sitting on the booth. They really had loads of different ones to look at, from your basic luminance based through the color pop and the more recent implementations as well. There's really a lot you can do with Hueforge now. It's really, really in depth, very impressive, and I'm looking forward to trying it myself pretty soon. For now, let's move along to the DFH booth to hear about the Flycron.
Nice to meet you. What's your name?
I'm B.
B, nice to meet you, B.
Nice to meet you.
So this crazy looking machine here, can you tell me like what kind of started it, what made you want to do it?
So we do, well, I guess I say every year, this is the second year we've done an April Fool's joke.
Yeah.
And April Fool's jokes, you get this cool thing that you want and then you're like, oh, it's fake, right?
Yeah.
So we like to do the April Fool's jokes for real.
Yeah.
So last year we did what we called rail cannon, which was basically a 2.4 with 2 linear rails on the x-axis, and we ran 24 volts over those 2 rails from each of the y rails. Okay. We did some electrical isolation, whatever, and it functioned, and so we had a 2-wire CAN board, just high and low, going, It's like, it's a stupid idea. It's like, oh, haha, very funny. Oh, wait, you did it? It worked. And I got it serialized by Voron, so like, it's ridiculous, right? So this year, we were racking our brains trying to come up with like a good April Fool's joke. And I was like, hey, what if we make an actual flying gantry? Because, Voron says they have flying gantries, but they don't really fly. They're belts and motors, right? So this is an actual flying gantry. There is no detent torque. These are encoders with fishing line going to them for physical feedback. You can see, can't really see it on video. This white one, I guess, is probably the easiest one to see because we had to replace it. So these are encoders up here. There's no motors, and everything is powered by about just under 4 kilograms of thrust total. So these are about 950 grams of thrust each. It is a PID controlled hovering gantry. The printer itself doesn't lift off. It's just like you saw, just the gantry. We have about 2,400 watts of 12 volt coming from a couple server power supplies back here.
Right.
We're plugged into a 220 line to get enough amperage to make it work.
How much? Does it like utilize most of that power?
So I think we lift around 65% throttle. The throttle curve isn't like linear, so like our main throttle range is within like 50% to like I think 80% is where most of our like really like the spike is, because that's a super non-linear response curve. Yeah. So we're actually the firmware is implementing like a linearization model. So I measured a bunch of thrusts, I fit a curve, and then I'm doing the equation to like linearize the thrust. Right. And it does print. We're printing with a 1.8 nozzle on it with 1 million layers. You can probably get some B-roll of that. It's like I've seen worse layer stacking.
I guess
kind of crazy.
I mean, I guess the main challenge is not necessarily the movement; it's the keeping it in one place.
Exactly. Yeah.
System for one layer.
And because it's so heavy, there's actually a pretty good amount of dead zone as far as hover goes. And so like, I haven't actually measured backlash on what I don't have actual numbers, but it looks like we're holding within like roughly 8 to 10 pulses of the encoder, and we have 2,400 pulses per rotation on a 10 millimeter diameter pulley. And I don't remember the math on what that works out to, but like, I think our resolution as far as sensing is around 4 microns. That math is probably completely wrong. And like, I'm going to guess we're holding around 0.1, solely based on like the artifacting you see in these. It does work. It is wicked loud. We measured it with a dB meter from maybe about a foot away, and it was 101 dBA.
That's a lot.
And that's at like 87% throttle. We have the throttle pretty limited from 50% to 87%, because on 110, if we do any more than that, it browns out with the peak throttle. We do have full throttle response on 220 like we have here, but I haven't tuned it for that, and so we're just running the old style.
So talk me through some of the technical challenges that come into using thrust as a means of...
Yeah, so this is the V2 of the gantry in a way. The V1 used these, which if we look at them compared to one of these, they're quite a bit smaller. Yep. These generate about a little over twice the thrust at the same current draw. These are like 100,000 RPM, but they are EDFs, which are rated for, they're designed to be in planes going really fast, and the load characteristics on the EDF are massively different at stall versus at speed. And so I didn't realize that and was working based off of rated currents, and these were just barely enough. You can't run these for minutes on end at 100% because with no at stall basically, because they were softening the plastic part. The motor would start to turn and then blow a bearing up, and I killed 3 of these. So we went to these larger ones. That was I almost gave up on the project. One of my friends was like, I'll sponsor a new set of EDFs, and sent me $200 for them, which was really sweet of him. So just building it has been, actually the build wasn't terrible. The biggest issue has just been firmware. So I'm sure you're familiar with Beacon. Dolligard, who's one of the main Beacon devs, I talked to him about the project, and he got really excited about it, and has written probably 4,000 lines of Rust for it. So we're running 4 STM32 black pills in here that are running Anchor, and so he's written a custom version of Anchor for us with stepper emulation for Clipper, which is something he's planning on doing anyways. We have a scratch implementation of D-Shot, which is like a digital ESC communication protocol for talking to the ESCs. That'll be reusable actually for controlling pumps and stuff that run on ESCs. And still trying. It's dual loop PID, so it's like a velocity and a positional PID. So we've had all sorts of issues on the firmware side and development.
I can imagine. I mean, nobody intended somebody to do this, did they?
It's so terrible, and it's funny because this is closed loop control, but at the MCU level. And so there's kind of a lag, so we can't actually home it because when Clipper detects the homing and where we actually are when we home, it's completely wrong, right? And that's one of the main issues with implementing MCU level closed loop control and servos or something. The same issue applies, right? It has to be in sync with where you're expected to be.
So how do you find zero?
So this has hard stops on it, so I can actually move the gantry along when it's at its minimum position, because it sits about a half a mil off of the bed. And so I basically just say, hey, I have a macro saying, hey, you're at 0.3 or 0.4 millimeters, and it just spins up the motors and then acts like that. So
Right, yeah.
it's kind of fake
The
homing.
layer height is quite thick, so like 1 mil, so it'll be a tiny
Exactly.
bit
So
of
like
that first layer.
exactly. And technically you can do that on a normal 3D printer, but you need to be consistently 0.05 or whatever above the bed, and then you know, and so like realistically, no one does that. The
Thicker layers are a little bit forgiving.
Exactly. Yeah. I mean, you'll still if it was like 0.2 or 0.3 oscillating, you would see like you'd see it really easily. But I mean, you can. I think in this print you can kind of see it. Maybe not. We had a taller print. I don't know where it went, but ground effect actually really comes into play.
Right,
So this is mostly PID tuned at like this height range to this height range, which is like where ground effect really is in effect. And once we get up here, we actually lose a lot of thrust because of the ground effect.
No longer
And so if you print something tall, you can see the base layers look really nice. And then once you get about a little bit higher than this, you'll see it oscillate, like in the print, which is one of the greatest like demonstrations of ground effect I've ever seen.
I suppose when you'll get to a certain point.
We need a second set of PID parameters that we load in based on height.
That's incredible.
Yeah, honestly, the biggest issue I've had is just with getting the power supplies to function, because on 100, so these are 50 amps at 12 volts each peak, and these will provide 1,800 watts total, and so fighting that has been the hardest thing, which luckily here we have 220, we can just cheat, but at my house I don't have it at my office, so.
So apart from that, it's kind of a normal, I mean, I'll say apart from that,
well,
the rest of it is fairly standard, is it?
So we initially intended this to be a simple build with like, we'll throw some motors on a normal gantry and call it a day.
Yeah.
When we sort of run the numbers, we realized that we had to go lightweight. So this is a fully custom 1010 carbon fiber tube gantry,
Right.
with CNC carbon fiber parts from Unger CNC. All of this white stuff is actively foamed ASA from Fadis that like, I think I measured the density at like 0.6 grams per cubic centimeter, which like is super, super light. It was printed at like 285, so a little too hot. And yeah, so it's essentially a fully custom gantry. The Z-axes are obviously completely different because it's for these. So like, it's a normal printer, except that it's a fully, there's not a single original Micron part on the thing, which is really something. It was a little more work than I intended it to be, but you know.
So, I mean, it's turned out beautiful as well as functional. So like,
yeah,
well,
I am blown away at how well it works. I got one print out of it before we came to the show, and an ESC overheated and turned off because I didn't have heat sinks and active cooling on them. So we did that when we got here, and it's been printing like we've been doing short prints because we've been bugging people here with the noise. We actually interrupted a couple of interviews yesterday, and so people weren't super stoked.
Yeah, that happens, doesn't it?
Yeah, exactly. I've heard talk that they might ban drone motors not next year, because they have drones banned, but not drone motors, and so they might next year be like, no drone motors at all, which is kind of funny.
A shame.
Yeah, but
Outside operation only.
exactly. You know, just got to run a 220 cable all the way out, right?
Stand in the cold for 2 days.
When we were talking about the amp draw issues, we were talking about like hooking up somebody's car and get off of an alpha car battery and like doing stupid stuff like that. So it inits, and our minimum throttle is like 50%, so it's going to go up to 50% throttle first. There's nothing around that's going to get sucked in, right? Goes out of the way. All right, I'm turning it on. We're getting loud. Let me know when you want it off.
Yes, that's okay.
And it just
the drop at the end is a confirmation.
Exactly. That's the Flycron.
Thank you very much for sharing it with me.
Absolutely.
Nice to meet you.
Yeah, nice to meet you too.
Oopsie daisy.
A seriously crazy and equally impressive machine. Now, let's move on to Voron design.
Hey, I'm Doug. I go by 120 Decibel within the Voron community. This is Voron Cascade. We're announcing it today here at RMRRF. It's going to be officially released with all the Voron documentation and manuals to the level people expect, probably in the late fall. The goal for me was to make a small CNC that functioned a lot like a bigger CNC.
Yep.
So my goal is to have things like it's got a door safety switch on it, it has feed hold, it has work offsets, tool diameter compensation, all the things you'd expect from a larger CNC, but I want to do it in a small package.
Okay, yeah, that really makes sense. What kind of firmware are you running? Is it sticking with Clipper or is it a more CNC focused?
No, I love Clipper. We love Clipper. It's a great thing. But for a CNC, the command queuing and all the batching is just hard to overcome, because when I want to stop it, I need to stop it like right now. This right now is running Gerbil HAL. I'm going to be testing it probably next month with Linux CNC. I've even had some talks with the Duet folks we're going to do some testing with RepRap firmware as well.
Great. So in terms of the control board and stuff then, is that, I mean, how similar are we talking to 3D printers? Can you use printed control boards?
This one right now is running an SKR3.
Right.
With BTT 5160 plus external drivers.
Okay, yep.
Because I'm running all these motors at 3 amps, 48 volts at 3 amps. So most step 6 would get I have a little trouble with that.
In terms of like sourcing and stuff, what's the situation kind of at the moment and what we maybe...
Self-source is probably going to be, what I'm telling people is mid to high 2000s. There's a lot of variation depending upon, like all the panels come from Send and extrusions from Misumi. To have them do that processing work is very expensive.
Yep.
But all the panels are designed, except for one, all the panels are rectangular with very simple hole patterns. So that if someone wants to lay it out and drill it at home, they most certainly can. There are a number of custom aluminum machine parts in here. We're already talking with Fabrico or LDO to carry those parts. But even like this is the most complicated machined part in there. And it's still just a pattern of holes and counterbores. There's nothing really complicated to it.
So in terms of complexity, it's nice and simple, but obviously you still need some sort of capability to get that far.
Correct. And all of the custom machine parts can be made on Cascade.
Okay.
So we still trying to do the RepRap philosophy of every machine is able to reproduce and make the next one.
Are we going to be looking at a kind of printed forward scheme for that as well?
We're talking about it.
Yeah.
Yes. Printed forward will for sure be carrying all of the printed parts, because there are still a lot of printed parts on here.
Yep.
All the motor mounts are printed because they don't take that much load. The load is primarily at the ball screw level.
Right.
So there are still a good number of printed parts in here, and PIF will be carrying those. Or you can do it themselves. They are, like, there are even things where we're doing 3D printed jigs for rail alignment that we fit. Like, for example, this is for the Y, and we've got a mount here for an indicator holder, so you can indicate it in with a dial indicator and make sure that everything's true and square for every axis.
Makes sense. In terms of the build complexity and difficulty, what sort of range are we looking at?
It's going to be in the higher range, primarily because there's a lot of alignment that you have to do, making sure everything is very square. The actual complexity of assembly is actually not that hard.
Yeah.
It's just there's a lot of bolts and a lot of nuts to clamp everything together. So it's very simple, but just the alignment process is more difficult.
In most of the Voron stuff we've seen so far, obviously the V0 used like, what is it, 15 by 15?
Yeah.
And the 2.4 and Trident the 2020, but we're going a bit bigger.
3060 for the most part, mostly 3060. There's a little bit of 3030 underneath the Y just because I needed some space. The enclosure frame is 2020 just because I don't need anything big. It just helps hold that together.
Just needs a frame, doesn't it, the enclosure, yeah. In terms of the enclosure then, is that, this is not just for the show, this is the enclosure?
This is the enclosure. We may end up, I'm debating whether or not I make some variants of this that are printable, just to reduce the amount of aluminum extrusion people have to buy. But that's still for discussion.
Yeah. In terms of release, is this releasing as of like right now?
No, we're announcing it today. Release will be in the late fall.
Okay.
With all of the standard documentation and manuals. That's to the same level that we.
What is the overall size here? If we need to clear space.
This is just about 500 millimeters front to back, about six to 650 side to side, and about 400 tall.
Okay.
The working area inside, the machinable area, is 275 in X, 220 in Y, and 90 in Z. This table is actually 340 in X and 230 in Z and Y, sorry, because I intentionally wanted to have work holding outside of the machinable area.
And with like the 2.4, for example, we're used to a couple of different sizes. Is this going to be, this is the size?
This is the size. If people want to scale up, they certainly can.
Of course, there's going to be stiffness questions as soon as you start to get too big.
Personally, I think if you probably went about 50% bigger with the way it is now, we can probably do it. Expensive.
We're keeping that high-performance machine with gardening tools. Right?
That's the Voron. That's our mentality. That's what we're trying to do. Is the only new gardening tool you need with this one really is a drill press to help drill some of these holes. Other than that, yeah, all the same parts and tools.
That's it now for the Voron Cascade. Let's move on to the Fabrico booth, where we talked to Sonat about the RatRig V-Core 4.
Nice to meet you, Adam.
Nice to meet you, Sonat.
Nice to see you in person for the first time.
Yeah, thank you.
Here in America. We're both from Europe, but we're here in America.
We've come a long way.
True. So I'm standing here next to the brand new V-Core 4. This was literally announced and unveiled yesterday. This is the iteration of V-Core 3. It comes with a few improvements. Particularly, we have now 3 modes that can be built on the same frame. We have the standard car XY mode that we already had on the V-Core 3, but now we also have a hybrid mode that uses 2 extra motors on the Y-axis to effectively double the acceleration on the Y-axis. Right now, this is just a test print. Throughout the day, we're going to push the machine to the limit. But the acceleration that this machine can achieve now is really off the charts, and something that we're looking forward to show off here at the fair. And on top of this upgrade, you can also have another mode, which is the EDX mode. So now we can have 2 heads on the same machine, and you don't need to do any rebuilds of the machine whatsoever. The same frame it can easily be interchangeably converted into these 3 different modes. We have a frame that is no longer uses joining plates, so it's all put together with quick connectors, and this allows for a much easier assembly process. The extrusions are milled, they are very precise in their milling, so there's no alignment or squaring issues whatsoever. We include a base plate that also really improves the alignment of the Z-axis and the alignment of the frame itself. And this new frame allows for an enclosing system that uses panels that are rectangular panels. They don't require any type of machining. You don't need a laser cutter, you don't need the CNC machine to cut them. They're super easy to self-source, and they also provide much better insulation than we had before. All of the XY plates, so the kinematics are all based on metal plates. So we got rid of a lot of the plastic that the machine used to have, and everything is metal inside the machine now. We really beefed up the MGN rails on the Z-axis for an even more perfect first layer. And we've partnered up with Beacon, so we have now auto Z calibration for a perfect first layer. The tool head itself, now it's a much more compact design that also has a metal skeleton. We are using Orbiter and Rapido Hotends. And we have a tool board on the tool head as well. So the experience is much more enjoyable right now. And another important thing is that the full kit now includes every single components for the wiring harness. Everything comes with pre-cut wires. Right. We have all the connectors. We have all the the spades. Everything you need to put the electronics together. You don't need to do any self-sourcing. Everything is included out of the box.
That's great. I see a very big looking disc in the bottom. What's that?
That's a carbon filter. if you're working with materials like ABS, in this case, that produces some fumes, we have the carbon filter to, you know, absorb those particles and make for a safe environment. We are calling it the Red Pack. It's not officially released yet, but some version of it is going to be released as an add-on for the machine soon. Another improvement is that we now have front tensioners. This makes for a much more convenient experience of tuning the belt tension, whereas before we had the tensioners on the tool head itself. And we've switched for these new Omron end stops, which have a lot more precision.
In terms of firmware, I assume we're still running Clipper or your RatOS?
It's running RatOS, which has now iterated to version 2.1, which is far, far more user-friendly than the previous version. Configuration of the machine is just a matter of, you know, pressing next and choosing some options on the wizard. We have a lot of new features coming with RatOS 2.1. In particular, we have resonance analysis, which allows you to isolate each axis and troubleshoot any resonance problems that you may have. It's a really useful tool to, you know, check your assembly and make sure everything is as it should be.
Can you tell us a little bit more about the price, maybe in comparison to V-Core 3? Like, is it a little bit more, a little bit less?
Sure. After you account for all of the things that you don't need to source this time, because, as I said, the electronics components are all included. You have the base plate, the enclosure panels are much cheaper to source than before. It's going to end up being actually slightly cheaper than the V-Core 3.1, even though the price of the kit is a bit higher. The overall build ends up being slightly cheaper, and it starts at around 1,200 plus VAT. For
I guess what we have is a better value, more included, and a slightly higher price to reflect the increase in components.
Yes.
Well,
I mean, there's lots of little things like the plates have gotten a bit thicker. They have more mounting points at the back. Actually, this is not the production plate, so maybe you shouldn't show it. But the production plate is slightly thicker, and it has more mounting points at the back, you know, for thermistor, for any types of things like rounding that you might want to put on the beds. It has some pins to dock the flex plate, so you don't have any problems with alignment of the flex plates. We have these new guiding systems for the bed to expand. There are these palm blocks that allow the sphere to move. It's a bit more polished, less parts, and in general the part count has severely reduced because the system is so much simpler to assemble to.
I guess that's a really great bonus, not just for you, but for the user who's doing the assembly. Makes assembly a little bit quicker, and sourcing easier for you.
For sure, for sure.
These larger rails, are these on all the sizes? So for the three,
yes.
You go 3 to 500 mil.
Yes,
moment, right?
exactly. They are only used on the Z-axis. The X and Y continues using the MGN12, but we're using HG15 on the Z-axis. Yeah.
I'm trying to think of things that I can see as different. I mean, tool headboard. You had tool headboard compatibility, didn't you? Towards the end of V-Core 3.
Yeah. So this is an evolution of the new tool head that we released for V-Core 3. We adapted it to V-Core 4, but it does have more or less the same features.
Yeah.
Orbiter, Rapido, toolboard mount, all of that.
So I've just spotted over here, we've got the CNC from RatRig as well. Can you tell us a little bit more about this machine? What kind of stage we're at?
This is the RatRig mill. We've been developing CNC machines actually for quite a long time. Many people, or most people, know us for our 3D printers, but we've been working on CNC machines about 4 or 5 years. For about 4 or 5 years, we started with the Killer Bee machine. Then we released the Strongholds large format CNC machines. And now we're bringing the expertise that we got from the Stronghold machines into a smaller format. And we're going to have the RatRig Mill, which is the one we're looking at right now, and the RatRig Mini Mill, which is an even smaller format. These machines are currently under beta testing, and we should be able to release them in the next quarter, somewhere around the next quarter.
And in terms of sourcing, it's going to be similar format to your 3D printers where you include everything you need?
Exactly. A full kit and a configurable kit are going to be offered. The full kit is going to have all the electronics included. The configurable kit, you get to choose which electronics you want to mount. Yeah, and that's pretty much the
What about
idea.
enclosure? Obviously, we've got it open here. Is there enclosure options?
There's going to be an enclosure. It's already designed. We didn't bring it to the fair because we just wanted to show the product.
Yeah.
But yeah, we're going to have enclosures for both versions of the mill.
So in terms of the overall design aesthetic, we can see it looks quite similar to the Milo, which was also released recently. Is there any kind of collaboration or like how long has this been design process? We don't want to pretend obviously it's like a copy or anything, but people are going to ask questions because it looks kind of similar.
Sure, of course. The design process of this machine actually started over 2 years ago. And you know, this is a legacy from the open source movement. Open Builds has released their own mills and mini mills. And this is just an iteration of a concept that already existed. I think probably both Milo and us took inspiration from the existing open source mills. And yeah, they do end up looking similar. But I mean, it's all about having an offer that each user gets to choose whatever they prefer, and we're just doing our part to contribute to the community, I guess.
And it's all open source as well?
Of course.
Continuing
Yes.
that, right.
Yes.
Cool. Well, thank you for talking with me today.
Thank you very
Nice
much,
to meet
Adam.
you at last.
Very nice to meet you.
Our next stop is RAK Robotics to talk about electrical discharge machining.
Electrical discharge machining is a thermal process. It uses joule heating to vaporize both a target material and a tool material.
Right,
So,
yep.
And the reason we have water in here is because we need a consistent dielectric breakdown for the plasma channel that forms between the two for the current.
Yep.
So when they get close enough together in that water, the voltage overcomes the breakdown strength of the water,
Yep.
and it initiates that spark.
Yep.
So a bunch of current flows through,
Yep.
and it vaporizes locally 2 little pits in the work and the tool.
Yep.
And then so we shut that off. After a certain period of time, we've put a certain amount of energy into that spark,
Yep.
shut it off. And that'll condense that work and tool material into a little hollow sphere,
Yep.
and that gets flushed away by the water. And then we turn it back on, and we do that 5,000 times a second.
Yeah.
So that's why when we actually are doing the machining, it doesn't sound like one spark after another. It sounds like a hissing.
Yeah, it's kind of like... To
And
put
that
it bluntly, it's one of the
vaporized.
worst sounds imaginable almost.
Right. It sounds like it's not supposed to happen.
It's a bit like the worst nails on a chalkboard kind of sound.
Yeah. And so every time I turn this on and I do it for the first time I jump, I'm like, oh, no, wait, no, it's supposed to do that.
That's okay, that's normal. That's a good
exactly.
sound.
So we can, on the PowerCore V2, we can go from 5 kilohertz all the way up to 20 kilohertz. So if you're running at a higher pulse speed like that, you're going to be running smaller pulse power.
Right.
In order to not blow up the motherboard.
Right.
And what that's going to allow is for you to have a finer surface finish on your parts. So you could potentially run like roughing speed with really high pulse power just to get the most material out of there.
Yep.
And then run around for a second pass at a super high pulse rate.
Right.
And you get a finer surface finish. Surface finish is kind of neat. So I also have a magnifying glass if you want to use that. But so this is the raw EDM surface finish right here in about, 20 millimeter thick aluminum with an interrupted cut.
Mm-hmm.
And then if we look, I think I have the other half of this, yeah. So this other half I took directly to a polishing compound. So you can go right from EDM surface finish to like a 2000 grit polishing and get a really fine surface finish. So that's really useful for hardened steel parts or like die components.
Mm-hmm.
This is the hot end that came off of that Ender 3 before I put the wire tool on it. And it went right back into the vat and got cut right from nozzle back to the end of the heat sink. So we did brass, aluminum, steel, and hardened steel all in the same cut, all in the same like wire length.
So does the machine really care? I mean, obviously you've done multi-material.
Yeah, we're doing multi-material
but
cutting.
Does it, not that it knows, knowing is not the right word, but
Right.
does it change the parameters for like,
No.
are there different optimum parameters for different materials?
Not yet. So that's something we're investigating how we can do in the future, but that's like a much farther goal.
Right.
So with different materials like this, there's going to be a difference in cutting speed.
Yep.
So when you're cutting like aluminum of a certain thickness, if you take steel of that same thickness,
Yep.
you're going to be cutting that material around 4.5 times slower than
Right,
you would
yep.
be cutting the aluminum. That's due to the density of steel and the boiling point of steel.
Right,
so we're
yeah.
concerned about the boiling points of the metal. And then so similarly, like
presumably that could, because that higher boiling point of the material requires then more energy for it to raise from the whatever waterbed temperature is up to that.
Exactly. Yeah. So it's the density and the boiling point. So like if I have a really like low density material and I want to boil that, even if there's a high boiling point, like titanium, for instance, I can still boil that more easily. It takes less energy to boil the low density material than the high density stuff.
Right.
So like if we look at titanium of a same thickness as that aluminum, that's only about 2.5 times slower.
Yeah.
So it's faster than steel, slower than aluminum.
Right.
Even though I think titanium has a higher boiling point than steel, but don't quote me on that one. We can also do things like tungsten carbide and hardened steel just as well as we could do any other conductive material. So the power core is not just for wire EDM. You can use it for die plunge EDM as well.
Right.
So if you want to make a 3D cavity in a part, you could take like say a little desktop 3018 mil, put a tank on that, machine some graphite, and then burn out that cavity for like dyes and different kinds of molds.
Yeah.
And that's something we're actually looking at doing relatively soon in-house for some injection mold.
And the critical phase process there is the same thing, but over just like
a wider area.
Just a kind of different tool for the interaction.
Exactly. So you're still using the same EDM power supply.
Yep.
One of the things that you can do with that, because die plunging is a much wider surface area thing.
Yeah.
So if you short that, you have a way better conductive path for the electricity to flow through.
Yep.
That's a way higher chance of blowing up the power core.
Yep.
So we put a couple closed loop outputs on the front of this. So you have an analog current output. So I think that's 0 to 3.3 or 0 to 5 volt output.
Right.
And then there's a digital 0 to 3.3 or 0 to 5 volt. I'd have to check what the actual higher limit of that is.
Sure.
But I've used the digital short alert output. So whether or not, like, am I making contact or not?
Right.
I've used that to do some die plunging and tap burning in the past. I'm going to be releasing the tap burning 3D printable files on printables pretty soon.
Right.
So, you could just, and the code for actually running that closed loop is just a little bit of Arduino. It's a really, really simple machine. It's simple enough where I could put it together in a day. Like, sure. So this is just a regular Ender 3 that we put our wire tool conversion kit on. The wire tool conversion kit has a bunch of 3D printed parts that are magnetically quick disconnectable. These are the parts that you could customize, do your own colors with. And they actually provide a safety feature where you can't accidentally touch the wire for the most part. So I'm going to start, I guess, right here with the Wago bank. When we're doing the wire kit, we didn't want to have people have to solder anything. We've got a grounding cable that goes to the aluminum endoskeleton. This is going to be type 3 anodized, so you're not going to be able to conduct to it with EDM. That's an interesting just side note. We can't machine through type 2 or type 3 anodized aluminum.
Yeah.
Like, we can't break that down to get to the material behind it. So this is going to be type 3 anodized when we ship it, so you're not going to be able to conduct to it. Having it grounded is really going to be super helpful that we don't accidentally turn this into an antenna. Because we've got high power pulses turning on and off thousands of times a second. We don't want to make an antenna
unless you ground it.
Right, exactly. So over here on the front, it's really similar to a 3D printer hot end, actually. The wire comes in through this Bowden tube, and it goes down into this pinch roller right here. And this is just two 625 RS bearings that are, pressed together with this, I think it's a 4.72 to 1 mechanical advantage lever. And that's going to grab the wire and hold it under tension when we start pulling it.
Right.
Down below that, you can't see it, but it's inside of this 3D print is a ceramic wire guide. So that keeps the wire from translating in the XY plane in relation to the tool head, so you keep it at an accurate position. Then it'll go down, and it's actually held under tension right now, and it's going around this idler, going down to this tungsten carbide block at the bottom. This is where it joins the circuit. That's where it's energized. And then it comes up around that idler and is spooled onto a waste spool on the back here. And so there's a constant speed 24 volt motor housed back here. There's normally a cover on there, but I took it off just to make it easier to show off. And this gets, again, put into the Wago bank. And so when we're talking about actually controlling this tool, we made this a 24 volt constant speed motor, so you could run it off of something like a standard desktop 3D printer. I wanted everything that was going to be interacting with the printer to be consistent with most 3D printers out there.
Yep.
So for this Ender, I just redefined the heated bed pin to be a fan in Clipper. And I'm like, okay, now it's digital. It's on or off. Am I pulling the wire? Am I not pulling the wire?
Yep.
And then with the power core, we didn't want it to be, okay, I plug it in and now it's sending EDM waveforms. Like, I don't want that. Like, that's probably a recipe for disaster. So we have to have an enable on here. And this is a, I think, 5 to 24 or 36 volt enable port. Just draws a few milliamps to turn on the microcontroller. No, it doesn't turn on the microcontroller. It tells the microcontroller, start sending EDM waveforms.
Yep.
Stock Marlin on the Ender has lower speed limits.
Right.
So, like, you can't go slower than 15 to 30 millimeters per minute in their stock Marlin config. I have such a hard time working with Marlin. I can never figure it out. So I just threw the clipper pad on there.
Yep.
And now I can go down to like 1 millimeter per minute speeds. And that's much more appropriate for doing like 3 millimeter steel or like thicker stuff like 1/2 inch aluminum. You're going to want to run really slowly on that. The ideal is that you have closed loop motion controls based on outputs from the power core.
Yep.
A couple people put that together already with Gerbil controllers for little like 3018 mils.
Yep.
So it's definitely proven out that you can do that, and those are open source forks of Gerbil. So you can find that online. I think it's the Desktop Wire EDM channel on YouTube has links to that, and he explained the whole way he did his conversion. So if you're cutting thicker materials, like say you want to do some 1/2 inch steel, you absolutely want to have a closed loop motion controller for that. And so we provided outputs for that, and there's really pretty easy ways to set that up.
Right. So what is the kind of goal of RaK Robotics at the moment with regarding this machine? Are you trying to sort of commercialize or just open source? Like where are you going?
Yeah, so the power core and the wire tool are available for pre-order right now on our website on RackRobo.io. So we're going to be shipping the power core and wire tool in just a few weeks. We're finishing up getting the rest of our stuff in from certain suppliers, like our aluminum extrusions. The goal, and we're also going to be open sourcing these as well. So you're going to get the hardware, firmware, and PCB design files for the power core, as well as all the hardware for the wire tool.
Cool.
So the idea is we generally want to create like a send, cut, send at home.
Yep.
You want a laser cutting service provider at your house. You don't have to wait 5 days, you can wait 2 hours.
Yep.
And that's the big thing we want to do initially.
Yeah.
So like a limitation we've always run into in the past when we're doing prototyping, when we're making motion systems, when we're doing different just even prototypes for in-house machine tools, when we're doing that type of thing, is that I have to wait a long time to get that metal made, or I have to go throw it over to our CNC mill, and that requires like 5 hours of saying like, okay, here's the part, here's the cam, here's the physical setup, and then you actually have to babysit the machine and make sure that that one-off part is actually going to be made correctly, and then you still might have mistakes in it.
Right.
Like when we're 3D printing, it's really easy to make a mistake and say, oh, I have to reprint this, but it takes an hour or 20 minutes. Like that's fine. So that's the big thing we want to do. So we want to make it easier for people to prototype with metal and just have fun doing hobbyist stuff with metal. And that's the start. But if you look forward to like smaller machine shops or smaller manufacturers in America, and even like look at us internally, like we want to be able to use this for tooling as well.
Yep.
So I briefly mentioned doing injection molds. That's something we want to try out. There's certain parts on our products that we want to injection mold.
Right.
And getting those made out of house is going to be, again, really long lead time, high price. So we want to reduce the burden that causes and the barrier to entry, as well as just like highly reduce the time required for that.
Yes.
And again, molds you can have mistakes on too. So molds, dies, hardened steel tooling, that's something I'm super, super interested in, because I do all the fulfillment stuff, so I'm always thinking about how to make that better. But so that's the start. And open sourcing it is probably the best way to actually get it out there and make sure more people are making it, and even, you know, potentially get us cloned, which would, I think, be a net benefit for everybody. Like more affordable EDM getting out there from more people is gonna be good. Like we even put it on our custom tape. The QR code for our GitHub says "clone us" right on there. So I had fun with that. I love doing the packaging too. That's so much fun. Oh, well, so we're not just working on the wire tool. We also have a machine that John built there. That's a 4-axis dual Core XY gantry wire EDM machine.
Okay.
So and that's built in a fish tank. John would be able to tell you a lot more about it.
Okay.
But so we're going to be open sourcing this design too after we make a few more revisions, and that's definitely a more capable machine than an Ender 3.
Sure.
And you'd be able to cut thicker material. You'd be able to do angles on it, so not just straight lines, but also be able to do chamfers or like dovetails, things like that.
Cool.
So that's something we're really excited about. I think it's gonna be a ton of fun.
Yeah. Great. Well, thank you very much for talking to me.
Yeah, no
It's great to hear about the project.
It was nice to meet you in person.
Cheers.
Another fantastic project which I'm hoping I'll be able to try one day. For now, let's move on and find out what BigTreeTech have on offer.
Here's a panda fur, which you can put on your bamboo machine and give it a little bit of your own character. One of the products that we're doing in the bamboo range, but there's a ton more. For instance, if you look, you got, I think Trevor just left the area with his hotspot. Let's see if he's still close enough. He is. Okay, so this is the Panda Lux inside here, and you can see the lighting is just, it's just phenomenally better than your standard bamboo lighting.
Yeah.
And if I, that's it, that's the installation. It's magnetic, it just clicks right up, and you're good to go. And it's a whole lot better. Of course, you know about the Panda Touch already. Yep. That's already been out for a while, but one of the things that's coming and that's new is you got the Panda Power, which will report power consumption back to the Panda Touch wirelessly for every print. You know how much you've consumed. Yep. But it'll also allow you to turn the printer on and off from the touch panel. And even if the printer is off, it'll keep the printer powered up through the USB port over here. Right. So it's a really cool little power solution. You can set it, look, when the printer's done and the chamber's cooled off and the heatsink is cool, shut the printer down. Don't just sit there.
But the screen stays on, so
the screen stays on.
Turn it back
on. So you've got, you just walk up to the screen, tap it, turn the printer on, and, and you're good to go. Cool. Quality of life improvement, but also if you're printing stuff for money, to be able to know how much power you're consuming, that's also meaningful. Yeah. So some great new products coming in the Panda range.
And but the Panda range is basically sort of targeted at the bamboo.
Well, as the name would suggest, the Panda and the bamboo are together. So it's targeted at the bamboo series. And here we've also got just it's pretty cool because it's actually SLS, right? Yeah. And it's a fan duct for the P1 and the X1 series, and it optimizes the airflow. You get significantly better cooling performance when you pop this guy on. So this is the Panda Jet, and we've got some really cool build plates as well. So this
for 14 hours
will get you textured adhesion without having to go up to 50 or 60 C on the bed, which prevents a lot of clogs that you would otherwise get in an enclosed chamber with a P1S or a X1C. This you can print. You don't even need to turn the heater on, but if you really wanted to, you could turn it to 30 and you would have no problem with adhesion with your PLA.
So that's going to be really useful for people that are printing a lot of PLA, PETG.
A lot of PLA within, and they want the textured surface.
They want the textured surface, yeah.
And they're in a P1S or an X1C. I can say I get clogs all the time when I try that. Yep. And it's frustrating. This solves that. Great little product. And then, of course, we got just some really cool texture going on over here. So it's just a build plate series that we've got going on. You got your PEI and your PYNO, and also a bit of satin on your plates there. So that's the Panda series, and of course the Panda Flow CHT. That's a collaboration with Bondtech, and then the Panda Revo, a collaboration with E3D. Quick nozzle changes, half low if you use the HF Revo, also half low if you use the CHT on there. So great little upgrades. BTT started as a company that was doing things for basically your DIY range printers, and that's, we will never stop doing that. So what have we got new in that range? We've got the Safe Clipper Shutdown Module, which we've actually been, you know about that. I know a little bit about that. You know a little bit about that. 24 volts in, 5 volts out, and as soon as the 24 volt rail disappears, it's going to let the single board computer know that it's time to shut down, and through two 20 farad caps, it's going to give it enough current to keep it powered up while it's doing the shutdown process. So you can shut down safely without any corruption happening over there. So SKSM, we got the CEB, a lot of tap changes and tool changes coming on the scene now. Great little board that fits nicely into a 2020 profile. You can just screw it onto the profile, take one in, and you get up to 6 out CAN bus power and CAN bus data. This is super cool. Have a look at that. Completely clear PCB. Yeah, there we go. There we go. So macros, it's got a little RP2040 on there, connect it up to your SBC and hit a button, you get printable keycaps that you can get from our website, and then you can define what macros will execute when you hit the button. On this board, the other thing that we should chat about is the universal turbo kit. So traditionally, when guys drive their CPAPs, they're doing it from a standard PWM output on a motherboard. That's not really the way that they like to be driven. This acts as a translator board, takes the standard fan PWM signal and turns it into something that the CPAP controller is actually expecting. And because of that, you get about 15 to 20% extra performance. So a really great way of driving your CPAPs, and it allows you to do it just using any 5 to 24 volt PWM output that you have on your motherboard. So
this is the BigTreeTech module. This is the controller.
That's your standard controller that you'll get when you get your CPAP, and this is just that universal board that allows you to drive it and get that extra performance. It's sold as a whole kit if you want it. We'll probably sell that separately as well. Sure. Very cool as well is the ERCF V2 kit. This is a project that we've been working on, and we'll be releasing a complete kit, and we've worked with the team to do some really, really great customizations. If you look inside there, there's a couple of PCBs that are uniquely BTT, and inside this little enclosure over here is a little secret that'll be released in a couple of months once the testing is done on it. That is also a collaboration with the ERCF team. So yeah, look out for our kit. That's coming soon. Very excited about that. And of course, finally, let's talk a little bit about the Clipper Touch. So we saw the Panda Touch, and that was a wireless group controller for your bamboo machines. Yep. But using the same hardware, we've written different firmware that you can just flash over the air back and forth. And now you get this wireless group controller and monitor for all your Clipper machines. So you just enter the Moonraker address details, and there it'll give you a nice summary of what all your machines are doing. You can select each individual machine and control them from your as well. You can group them and send out group prints. So some really, really cool functionality coming to the Clipper Touch in the future, and that should be out also in about 2 months from now.
Nice.
And if you look at this, you'll also notice that there are, well, that's the CPAP running, and it's kind of noisy, but once you close things up, it's actually remarkably sealed off. But when you do look inside here, you'll see metal parts everywhere. This is all metal, all metal. So this is the CNC V2 kit, and it comes from a company called Chaotic Lab that BigTreeTech now owns a majority stake of. So yeah, we've taken control of their development and marketing, and that's why we're displaying their products now. So this is the CNC V2 kit. It does some great things for the performance of the machine, but also it just looks really, really great and makes building it a whole lot easier. Right, far fewer printed parts. So that is a little summary of everything that we have going that is new. Of course, we've got the Pi 2 and the CB2 as well. Pi 2 is we could call it, it's got the equivalent power of a Raspberry Pi 4, but it takes 24 volts in. Let's go and have a look at that. So here's the Pi 2, 24 volts in. This time we support CSI and DSI on the product. It's got Bluetooth. It has a built-in 32 gig eMMC, so no need for an SD card. Also, eMMC is, objectively more reliable than an SD card.
Yeah, of course. Yeah.
So really, really great little product there. And we've actually also entered a partnership with Abico where all of our Pi products come with Abico pre-installed. All you need to do is enable it if you want to use it. And you'll get 25% off if you do subscribe. And if you buy the AR version of our product, then you get 3 months free of Abico Pro subscription. So yeah, and of course the CB2, which is just the compute module format of the BTT Pi 2, also with 32 gig eMMC on board. Very,
is that compatible with the older Pi 4 adapter?
Yeah, you just pop it on there, pop it on there, and you get all the functionality. Remember, the Pi 4 adapter already had the CSI and DSI connectors on the back and front. Yep. So it was built with this in mind.
Great.
So yeah, beautiful little breakout board for it.
Good stuff. Excellent. Thank you very much.
Thank you. Thanks for coming around.
As you can see, loads of new things coming from BigTreeTech. That's always great to hear. Now let's talk to someone I'm sure you'll be a fan of.
I'm Victor from Oli 3D. We manufacture part cooling fan nozzle kits. Currently we make kits for the MK4. We have one for the, that's hard to see right now, for the Ender 3, but you have to have the Micro Swiss extruder, direct drive extruder on it to incorporate our kit. And we also have one for the MK3.
So your idea here is to try and improve cooling and kind of printing performance in general?
That's the direction that we were going. And the way we go about doing this is we have these removable part cooling fan nozzles, and they are made from Formlabs high temperature resin. After the resin's been cured, we take it to get Cerakoted. And it's not your typical Cerakote. This is a piston coat.
Right.
It's they call it piston coat because it's applied to the top of the piston in the combustion chamber.
Okay.
And so that provides us better heat deflection.
That probably allows you to get a little bit closer to the nozzle without any risk of like melting or overheating. Or
yeah, exactly. So with all those things combined together, what it gives you is going to give you the ability to print overhangs at 80 degrees without any problems.
So if someone wants to do this kind of change to use your system, how much kind of
work is involved?
How much work is involved?
It all bolts on the way the factory set it up.
Okay.
Like this one, for the MK4, there's just one screw holding this whole assembly on. And remove that screw and put our kit on.
So there's very little complexity if you, if you're able to kind of maintain your own printer.
Yeah, that's going to be so easy. Yeah. Even for the MK3, it's the same thing. Right? There's three parts to it, but it's all the same as you would see in the factory. So this is for the MK3, and also held in by magnets, and plus, it'll save you, headaches when the material lifts up and grabs it and knocks it off.
What kind of price point are your upgrades at?
For the MK3, it's $50 for the whole kit. It comes with everything you need to do direct bolt on.
Okay.
MK4, this is $47 online. Right now we have a show special. We're selling it for $45.
Okay.
But yeah, there's only 2 parts. And then coming soon, we're gonna have a Mini. Right now we have a kit on there, but it's the same kind of deal. We route the wiring from the back, clean it all up.
Do you have to use the extra pointed nozzle, or is that just
that's just
design?
No, that's just for this specific design. If somebody wanted to go that route, we have that, ability to do that. Right now, the other Mini has a standard rebuild.
How long have you been doing this?
For a while now.
Yeah?
Yeah, it's 3 years maybe, going on 3 years. Yeah. It just took a while to develop
I can imagine.
And test it, and then once it was kind of, okay, we got it where we want it, then let's go ahead and release it.
Making a Ducts is kind of easy. Making a good one is difficult.
Yeah, it takes a lot of trial and error. And what we do to test our ducts is we print this test piece out, a pyramid calibration test that we designed ourselves.
Mm-hmm.
And that tests overhangs, bridging, stringing, and
if people want to try this on their own machine to see how they compare to your upgrade
printables, they could go on printables.
Yep.
And download it. And we have another versions of this where it's broken down into pieces where you don't have to print this entire piece. Where you could just print individual
whichever
parts,
element you feel like you want to test.
Yeah, but we recommend people printing the ball cone tower first. That'll give you a good indication of, your speeds. Mm-hmm. Are you going too fast? Not allowing the fan to cool the part, not giving enough time, you'd have to slow it down.
Sure.
So you slowly start building up. After you print this, you do the overhang test and tweak that. And then after the overhang test, you do the bridging. Then after the bridging, you could go ahead and print the whole pyramid calibration.
That's really cool. So if people want to find out more, where they got to go to learn more about you?
Oli3D.com. you'll find us there.
Well, it's been really nice talking to you.
Oh, nice talking to you too. No, thank you.
Hope you enjoy the rest of the show.
Oh, you too. Thanks.
Great, thank you.
Carrying on our journey around the South Hall, I bumped into Deposition Sound, who create 3D printed speakers. So let's check them out.
My name's Yvonne Brudrick. We are Deposition Sound. Who's the we in the equation? It's myself, Yvonne, and my brother Waldo. So Waldo and I, we decided, you know, we really like audio and we like 3D printing, and we're makers. We're people that like to build things. So let's bring it all together. And I don't like, you know, mediocre audio. I like really good audio.
Yep.
So we decided let's put those two together, do a good job of crossover design, choose good components, and then put it inside of a stiff 3D printed enclosure. So what we have here are 3 different models. We've got the FDM5s, the FDM Geos, and newly created FDM4s. We think it's something. There should be something for everyone. If you enjoy parties or a little bit more laid-back sounding music, the FDM5s are definitely for you. The FDM Geos are more for like mastering and mixing, as well as critical listening.
Right.
They cut through very well. They're almost a ruler flat frequency response speaker, and in my opinion, they're. Well, I should say it's my favorite speaker personally. But yes, I'm the primary designer for all 3 of these. I've had a lot of really good input from my brother in terms of aesthetics and how to assemble and you know, change things out a little bit. But the FDM4 is a bit of an amalgamation of the Geos and the 5s. We do some really cool stuff on the FDM4s with a really long port to extend the bass, because we're using a very small driver that doesn't normally produce a lot of bass.
So it's all 3D printed in like 1 or 2 parts, is it? You don't have, there's like minimal assembly?
2 main parts, the front baffle and the cabinet.
This is the interior.
Yes, so that's just the port for that. So yeah, it comes together on 2 halves, or with 2 halves, yes. And you just need CA glue or a decent 2-part epoxy to make it work, but we prefer super glue. It's fast. We even hit it with an accelerant too to make it work even faster. I know with 3D printing, the idea is to push the boundaries and really challenge our manufacturing techniques a bit. But we wanted something more entry level that would look a little bit more conventional and attract people to the idea of, oh, that can look like that and also be 3D printed. That's why we started with that look. So it's more timeless, classic look. Yep. I like the geodesic look. The FDM Geos quite a bit more, just personally. And with 3D printing, you can add the port anywhere, to the back, to the side, to the top even. But the 4s, that was, in my opinion, our biggest step forward in design, in aesthetics. And I think what drove us to that shape overall was just, you can't really get that with MDF or birch plywood without a lot of work.
So if people want to get hold of them, what is it you're like selling or providing?
So what we're selling is everything except the plastic.
Okay.
So we sell the woofer, the tweeter, the crossover, the wires, the connectors, even the stuffing that goes inside of it to reduce the standing waves.
Yep.
That's all included. So the only thing you need is to actually print the cabinet itself.
Right.
And we sell it in pairs. We don't sell singles.
Okay.
It's kind of weird.
Yep. So in terms of the electronics, the speakers are kind of off the shelf, are they? But the crossover and stuff is things you've designed?
Exactly. So the speakers themselves are off the shelf, common off the shelf parts that you get from Parts Express. But the crossover is where the magic happens. So I spent a lot of time in Extem blending the tweeter with the woofer, and we have a gentleman named Matt in Illinois who does all the building of the boards themselves. He does an incredible job. They are pristine. Does a much better job at soldering than I can. So that's kind of the cool part with these kits. You don't have to solder. There's nothing that you solder here. The only thing you need a soldering iron for is for the heat sets or the heat threaded inserts. That's it.
Great.
So yes.
And in terms of the materials you have to print it out of,
Yes.
PLA, PTG, does it matter?
You can do either. Just if you do print it out of PLA, we don't recommend you take it outside. Large flat surfaces like to warp when they're made out of PLA. But yes, you can get it really exotic too with ABS and glass fill filaments as well. There's a handful of people out there that are looking at carbon fiber filled filaments as well. So that's kind of cool. But we haven't played with that. We kind of started with PTG knowing that it's a tough material. It has slightly better sound dampening qualities than PLA. PLA likes to ring a bit.
So your recommendation would be PTG?
My recommendation would be PTG, but if you have PLA, it's perfect. You'll be fine. But we add, some additional details like, I'll pick this one up. We even put foam pads underneath. I didn't turn that over earlier. So that will help a little bit if you're worried about structural resonance. It'll help damp that out a little bit.
In terms of like technical specifications, that sorts of things, what are we looking at?
So both speakers, I think actually all three speakers are rated at 8 ohms impedance with a ohm rating of 6 or 6.5 ohms. That's the lowest. That's where it bottoms out. So you need a 30-watt amplifier to run them. You can go less than that. You're just not going to get very loud. The FDM5s and the FDM Geos are about 87 dB sensitivity. The 4s, we haven't quite measured those yet. I'm going to guess it's going to come in around 85 or 86. A little bit lower. You need a little more juice to run those. But yes, about 6.5 pounds, almost 7 pounds for one speaker on the FDM5s, and a little bit less than that for the Geos.
And the sizing that we see here is all kind of similar in terms of like volume. Do you have like smaller and bigger options?
So there's more volume in the 5s than there are on the Geos, but they've all been tuned correctly
for the drivers that you have.
Correct. So we measure the small parameters and use WinISD and some old documents from the 70s to properly size and get the right base extension that you need. So everything's a base reflex design, except for, well, classically the FDM4s are a base reflex design, but the port is 35 inches long. And that's almost like you're starting to get into transmission line territory. But it sounds great. For a little woofer, you can really get a lot of good extension. And we think that they really offer a lot of value too. So all of our assembly guides are online. So we have a separate assembly guide for each speaker. We're working on this one. But yes, it's all online.
What kind of size beds do you need?
Oh, yeah. So the FDM4, you can print on an Ender, all of these. I would say the smallest size printer you can use is a Bamboo P1S or a P1B or a Carbon.
So that's about 250, whereas this is about
200. Right. So this is about 200, this is about 250.
And the one at the end?
Same,
okay.
So that's another 250.
250.
Yeah, but you can find us at depositionsound.com. We're also on Twitter.
At Deposition Sound?
At Deposition Sound, yes. That's us.
Very cool. Well, thank you very much, Ivan, for talking to me today. Pleasure to meet you. Thanks very much.
Yeah, definitely.
I think that's probably going to be a project of mine sometime soon. Anyway, now let's move on to hear from Beacon, who have something new which you might not have seen yet.
I'm Matt.
Matt, nice to meet you, Matt. Adam.
Nice to meet you, Adam.
So, Beacon, what's the latest and greatest?
The latest and greatest is contact detection, nozzle contact detection. So using the sensor data with the Beacon, we're able to detect the exact point when the nozzle contacts the bed. So I'm going to show you a demo of that now.
Okay.
So you'll see it's diving down to probe the steel. It can also support other new materials like thinner layers of glass. Yeah, so it's still using the same technology. It's based on inductance and eddy currents, except in this case, we're using it to look for the event when the nozzle comes into contact with the bed. So looking at the sensor data as you approach, as you contact, and then stopping as quickly as possible.
Okay.
So same technology, new application, new implementation. It's got entirely new firmware to be able to do it as quick as possible and get just perfect timing on when the nozzle contacts. So if you're really forgetful, like some other people, and you accidentally leave your magnet on the bed with no plate, it's low enough force that you're not really going to do any damage. We've even had people in the beta program print first layers on their magnet. Not recommended, but you can do it.
So this beacon contact, right, is the name?
Yes, beacon contact.
Does this do both, or is it this instead of what you had before?
Right, so it's going to be both. I'll do a little demonstration of what a calibration looks like now. So one of the issues people brought up with us with Beacon is that they might have a lot of plates, they might use different nozzles, and so if you change a nozzle, you change a plate, you need to recalibrate.
Yeah.
Now that we have contact detection, we know where the bed is, we can calibrate automatically. So there's going to be new workflows where you can figure out your Z offset, you can figure out which plate you have. You don't even have to calibrate in advance. You can just put a new plate on. It could be from a different machine, same machine. It'll calibrate on the fly, and then you're good to go.
There's still like one offset value that you have to calibrate, but then as you change parts of the machine, that value remains the same.
In this case, and for most machines, you won't even need to do that.
Okay.
Just because the force is so low, there's no moving parts. It's the physical nozzle, the whole assembly touching the bed. There's just no offsets there. So if your nozzle's clean, you have to deal with a little bit of ooze. If your nozzle's clean, you get 0. So it's very likely going to become a zero baby stepping solution for people. So I just restarted the machine. I'm going to show this would be a clean boot.
Yep.
It hasn't been homed. It could be a new plate. We could remove it if we wanted. So it's going to first do the contact homing. It'll take a couple tries just to make sure everything is going good, to get it perfect. Now that it knows where the bed plate is, it's just going to advance into the standard calibration people may be familiar with. So it's going to measure the displacement mapping for the sensor. So now we're good. The machine's homed. We have a brand new plate we never used before. We know exactly where 0 is, and our beacon is calibrated.
Okay.
So if we want to advance straight into mesh, you're good to go.
If you're doing like the quad gantry level type of thing, you can use that nozzle probing for that as well?
Yep. So if you want to use contact probing for tilt adjust, for quad gantry leveling, for bed mesh, it's going to be slower. But if you want to try a new material like glass, which is now for thinner sheets of glass, you can probe it now. So if you wanted to do a physical bed mesh on a sheet of glass, you could do that now with the new technology. You probably wouldn't want to use scan mode with glass, but you'd be able to run it in contact mode.
Okay.
It also solves a problem for people with beds with large permanent fixed magnets that are known to cause issues with scan mode. The way contact detection is done, they're not affected by the magnets. So if you have those types of beds, like those from Mandela Roseworks, you could do a contact mesh. Or if you're having some issues with, say, tool head tilts that are just causing you to get bad mesh results in general, you can switch to a contact mode if you like. The software will still support both. If you want a workflow that uses only induction, you can still do that. And if you want to switch to contact, you can also do that.
In terms of requirements on a printer to be able to add Beacon, what kind of things do you need to consider?
Yeah, so Beacon is designed for Clipper. It needs to have the Clipper firmware on it. You'll need a USB port available for attaching the sensor. And you'll need a way to mount the sensor to the machine. So it's compact and fairly flat. It does require a little bit of keep out area above the sensor where you don't want to have too much metal. But if you can fit the sensor underneath the tool head near the nozzle, you get contact probing, you get scan mode. We're really excited because people are going to be able to use this to get just perfect layers. There'll be workflows where you can use different materials, temps, different bed plates. You don't have to worry about making simple mistakes. It's just going to be so much easier.
What are we thinking about, like availability? Where and when do we get this?
Yeah, so the new contact feature, it's a firmware update, software update for all beacons. If you ever have a beacon, any revision, it works with it. It's going to be coming out in May.
Okay. And that's where, like, what resellers? You're selling yourself and as well as resellers?
Yeah, so you can get us online, direct from our store, beacon3d.com.
Yep.
We have new resellers now. We have CR3D in Germany. We have the Annex EU store in the Netherlands. And we're going to be, we have Raven 3D Tech in Australia, and we're adding more as time goes on, trying to help get these out there.
Good stuff. Well, thank you very much for your time today. It was really great speaking with you.
Thanks very much, Adam.
Cheers.
Moving from precision probing over to precision manufacture, let's see what Swiss 3DC have going on.
So, hello Adam, nice to meet you here.
Nice to meet you too.
From England.
Yes.
It was cool to see you.
Yeah, it was a long journey, but I'm glad we both made it.
Yes, and for me it's the first time I'm presenting on the RepRap Festival.
Oh, that's very exciting.
A few ones, but not there. So for me it's really tough, and today is the launch day, this morning at 9 o'clock.
Very excited.
The launch of my new device. Maybe I should show you how it works.
Yeah, go ahead, show me.
So, just to open this, you just need to unclip it here, take it out, and you have your nozzle in your hands.
So that's what gives you a really quick nozzle swap.
Exactly. And the other thing is, it's a very long melting zone, because compared to this, it will be shorter melting zone than on here for the same height.
So about how many millimeters is this?
That is 19.6.
19, and what do you get on this one?
22.5.
Right.
And I can go down here. We have 33 millimeters. And for the Bamboo Lab, we have 24 mil of melting zone.
So if you're going to upgrade from this to this, but you get more melt length, how do you achieve that inside kind of the same sort of package area?
I think I'm very short here for the heat break tube.
Yep.
Very thin as well. And I have a solid part because all the sides somehow are holding the device, the nozzle. Nozzle is the central part. But once you're tight here, everything is nice and stiff.
Yep.
And that makes 5 points of fixation with no screws, nothing, that you don't tight too much or whatever.
Yep.
So it's very nice and tight. And once you've put it inside, you have a little clip in here.
Yep.
Just put it in, and this holds the whole thing together and doesn't move. So that makes it stronger. Of course, you can always damage it if you go too strong. If you make an accident with a printer, like a card.
You can damage anything if you try hard enough.
Definitely.
Yeah.
So it's very light. It's very strong in matter of heating. Here, another detail. You have the heater. It's a MCH heater. And you can just, it's a symmetric parts. And you have the same here. You can do 2 heaters, 30, 40 watts or whatever. So it's very easy to implement. And for this one here, you can see it's a 33 millimeter. You see here. And here again, everything is very simple to take on and off.
So in terms of nozzle availability, like obviously you want to be able to switch nozzles. What kind of nozzle things, what options do you have for nozzles?
We will have 04, 06, 04 is common, 06, 08. Stainless steel, hardened stainless steel. You can see we can mount it directly on the Hemera, old version, new version. Same thing. All the time, very easy to take in and out. It's a simple part we just put in, and we can adapt it on any kind of heat sinks. That's typically how it is. You just change this part to fit. That's for the Bondtech end part. You just add these things. And here is a spacer. With spacer or without spacer, just to be able to fix it on any kind of printer.
So like the kind of hot end part is common,
yes,
and then the mounting part changes depending on where you want to put it.
Yeah, exactly. Very simple way to do it.
So what's the availability? Are they out now, coming soon?
They would be coming soon by beginning of the summer.
Okay.
They should be by beginning summer. You can see here for the Sprite extruder, exactly the same, just modified slightly. And again, same thing, same height, or a few less than a millimeter difference. But again, a much longer melting zone.
Yeah.
And that helps to improve. It's like if you just add on here Volcano.
Right, yeah.
Volcano is 21 millimeter. This is from 22.5, 24 to 33. And you can imagine can go higher.
Yeah.
So that's more or less all. And we just mounted here on the Prusa Mini. The exact same height. From this one to this one, exact same one. Or if you don't want to change the heatsink, you just, like I showed before, adapt it with a spacer and it will be a bit longer. That's all it changes.
If people want to find out more, where's the best place for them to go to?
Well, on the website, swiss3dc.com.
Yep.
It will be available. The shop will be open before summer. One more thing is just not to forget, it's patent pending.
Okay.
And it's already gone forward first step, and it's already approved some part of it.
Cool. So that's exciting.
There's another little thing here.
Yep.
So that's a basic V6 nozzle.
Yep.
But it would have nearly the high performance as a CHT.
Okay.
With an inner part that makes the melting zone very efficient.
Right. Can you share a little bit about how that works?
It's just a tube that has been inserted,
right.
And it's a tube that has been pinched.
Right.
And that's a patent as well.
Okay.
To make it this way inside. So yeah, it's a very simple way of doing it. That makes it different, and that makes it valid for a patent.
Yeah.
So it's just a V6 nozzle. You can put it in any other nozzles we have for MK. And the great thing, replacement part for what is existing.
Yeah.
And that's a cool thing.
Great.
So I hope you like it.
Yeah, looks interesting. Well,
Yeah,
thank you for talking to me today.
Yes, thanks to you.
Hope you enjoy the rest of the show.
I will hope to get around to. But people were very fun for this until now. They really just, the face they're doing each time, oh. I love it. I should have a camera behind.
Well, it's been great to see you again.
Thank you, Adam.
Thank you. Cheerio.
Swiss 3DC really has come quite a long way since their first toolless hot end, and I think this one looks pretty promising. Now, let's talk Division Miner.
We're really showing off our nanopolymer adhesive here because it applies to every machine on the market. It's kind of ridiculous. We made it for the peak and the ultimate, the high temp engineering thermoplastics that we use every day and serve our customers with. And it just happened to work with PLA, PETG, ASA, ABS, you name it, everything but polypropylene. And it's just been an amazing product for the last 6 years to like provide, to have, and just have everybody come up and thank us for it. It's been like, yeah, it's awesome. It helped us, we can help you. And then of course we brought our 22 IDEX V2 to show off the technology, because a lot of the technology in here actually came from the consumer market. And as you can see, we've got the bed dance going. Now this is really designed for, you know, the high temperature chamber so that you don't have to open anything up and let the heat out and the cold in and change the thermals, because you have to soak all the metals. They expand, and when you're doing super precise 3D printing, it's really important that nothing shifts and it all stays locked in. So with this, we're able to mechanically self-level and on top of mesh bed leveling. And it also opens the door for 5-axis printing. With this amount of articulation, you can actually get 90-degree overhangs with no supports.
That's amazing.
Absolutely incredible. The software side of things is really catching up with that. In the next year or two, we expect to see a lot more moving forward and usability in that department. But if you look inside the machine, up here we've got IDEX. Now for our customers, that really means printing 2 parts at the same time. You're getting 2 printers, 1 on each head, and you can do duplicate or mirror mode. But you can also do multi-material, multicolor, or things like soluble supports. Now on here we've got the Bondtech LGX extruders, very good, the LGX Pro, and the Slice Engineering Copperhead Hotends. So we're using industry standard, top of the line parts that are the best of the best in the industry, regardless of its consumer market or professional market. But the fact is, it's not proprietary. We're also using the Duet electronics, and that is an open architecture that allows you to do any kind of modifications you need to on the machine. We've got several aerospace companies that are actually making very interesting modifications to the platform, and that's the whole point. We have a great system, and it's off-the-shelf parts, so if it breaks down and you're in a production environment, you can order it on Amazon. You can go to the local electronics store and get the components you need if you can't wait for us to ship you the parts. So that's really the bread and butter of what we do. We also have a whole line of 3D scanners, which we didn't bring to this show, which we totally should next time.
And if people want to find out more about Vision Miner, where they can get the adhesive, where do they go?
Well, the visionminer.com, of course, /adhesive, if you want the hot link for that. For the Rocky Mountain RepRap Festival, for the rest of the month, it's buy one, get one free. So use the code RMRRF on the full-size bottle, or RMRRF 50 for the 50 milliliter bottle. But we're also on all the social media. So Instagram, Facebook, YouTube. Our YouTube channel is definitely a lot of education. Big part of what we do is support the machines that we sell. We get it because we think it's awesome and we want to use it, and then we use it and know it and understand it, and that allows us to support our industrial customers and educate the community. So check out our channel if you want to learn about all these high temp, peak and ultim thermoplastics and how it's being used in industry. And if you're interested in getting into it, you've got a business where you could use these types of parts, whether that's automotive, medical, oil and gas, or even aerospace, definitely reach out, give us a phone call, shoot us an email. We're always here to help.
Excellent. Wonderful. Thank you very much.
Thank you, Adam.
Cheers.
Good to see you.
I did pick up some of their bed adhesive while I was there, so I'll be testing that out soon. For now, let's move on to the LDO booth and hear from Positron.
Hi there.
Hi.
Nice to meet you.
Nice to meet you.
So, you're running Positron, right? Is that right?
Yes, I'm the general manager of the Positron project. I worked with Kraylin,
right?
And we are the team that has brought Positron to life from what Kraylin originally worked on.
Great. And your name is?
My name is Nomad or Anthony.
Excellent. Nomad or Anthony. Nice to meet you. So, Positron, we've heard about it a little while back. It's been sort of in the background now. What kind of stage are we up to in terms of people seeing this in their own hands?
About a month out, actually. So this is the version 3 that's based off of Kraylin's original design. We actually designed this with Kraylin. But he has moved on to a job which he can't directly work on this anymore. So he made me the general manager of the project, so we continue working on this. This design is great for, a couple of college students that made this. We use synchro mesh belts because that's what was available to us at the time. But we realized that this is not the best sort of printer that this could be.
Yeah.
For example, I'm going to put this on the table here.
Great proof of concept, shows off the idea, shows what you want to do.
Yep.
But with lots of room for improvement.
Exactly. So if we look here, one of the things is like this Z-axis is a little bit wobbly. Like that's just the holder here.
Yep.
But if we come over here to our 3.2 designs, we can show you we've improved the design of the bed itself. So we use an edge connector here. And on the back is an ITO coating. So this is all heated with just a voltage applied to that ITO coating.
That's kind of insane considering you can still see through it completely as if it's just plain glass.
You can see the first layer without any problems. So if you see a problem happening with your first layer, you can fix it immediately. You don't have to wait until, however long, or try to look underneath the nozzle to see if it has any problems.
Yeah,
so
it's definitely the best first layer visibility I think I've ever seen.
And that's something we're really proud of. But back to the bed connector here. So what we did to get rid of that wobble is, one, we increased the tolerance on the Z-axis linear rail itself, so it doesn't wobble as much anymore.
Yep.
But more importantly, we added these ridges here in both the connector on the Z-axis carriage, as well as this unit entirely. So when it actually clips together,
it's forced into a specific location. It's clamped down and can't swivel or twist.
Exactly. Those are just part of the improvements that we made. I'll get that attached later. Because actually, I can just turn this off and I can show you the other great thing. So we moved to 3mm belts for our kinematic system. Now, we originally went with synchro mesh because, again, that was what we had at the time in the university. But once we started working with LDO, they were able to source these 3mm belts for us so that we could, make this easier to work with. With the synchro mesh cables, we've had a few snap in our Bana units, and those cause a tangled mess. It's terrible.
Bit of a cleanup situation.
With this, I can easily take off this idler, just keep tension on this, replace it, no problem, and put it back, and in a couple minutes, I'm able to do whatever repairs we need to. If we lose tension, it's easy to get back up and running again.
Great.
Now, the other thing that we've done is, one thing that's a little bit difficult is we got these two slots here. Now, these two slots are for the carriage to slide into. So, on the back of the printer here, we added a silk screen so that you can line up the carriage exactly where it needs to be, so that when you go to unscrew the back and release the tension on the lever, the whole unit just folds down. Oh, apparently you missed the mark a little bit. Just like that.
That's incredible.
And now the other thing that you may have seen here, so if you look at the original 3.2 unit, this is our tensioner for the Z-belt. This is great. This works perfectly fine. But over here, we're using a spring at the top here, so that allows it to fold while still keeping tension. And when it's up in the upright position, you can actually see how that kind of moved. This flips up and clips into place so that if there's any weight pulled down on the bed, it doesn't move.
So in this version, you get the tension and then fixes it when you're in the kind of printing configuration.
So in this old version, if you pull weight down on this, the spring will compress and that could cause problems. So if you have a really heavy print, you can see a bit of squishing.
Yep.
This solves that problem. So again, you can see that kind of compress as it folds down. And then it's a little complicated because we still have it hooked up, but this moves right there, screw goes in there, screw goes in there, goes in the filament box. So the footprint still fits.
That's crazy.
And we are very proud of that. Additionally, in the old version, so you can actually look here, you can see little channels right there. These go into that channel so that no matter what, this always goes up and down exactly the same every time. In our original version 3, we didn't have that. So the printer would often, the Z-axis would just pop off.
Right.
And it would be just a pain in the butt getting it right back into place and then screwing it in. That's not a problem anymore. So we really worked hard to make this more user-friendly, just better design as a whole, and far easier to build.
It makes it very, when you explain all these details, it's really clear why it takes that time to get it right, because you're solving a lot of really unique problems. Like a lot of other printers, they're similar enough where if they have a problem, they go, well, these people solved it that way, so let's try that. And you've just like, we've just made a whole load of unique problems and now we have to solve them.
We were going to go to market with that original V3 design, but in our beta tests, we just found way too many problems. And we weren't happy with the result. And we wanted to make sure that whatever we sent to people was actually good.
Yeah, absolutely.
So we spent another year working on everything, making the version 3.2 and just improving. One of my favorite things that we've done is in the version 3, we have Raspberry Pi 02W inside the housing. That's great, but that takes up space in a very limited compartment.
Very limited.
So this right here is the screen for the unit.
Yep.
Has a little flip out here, so it just deploys nicely. This is not only your screen, but is the Raspberry Pi CM4.
Right, okay.
So this hooks up by one USB cable to the printer, and here's just one that's already hooked up, so that you can control everything.
Flip a screen, and that's all just by one USB cable. That's brilliant.
Now, one thing that's fun about that is, hey, say something goes wrong, you don't have to dismantle your computer or your printer. You can just unplug this, plug this one in, easy upgrade. Nothing else has to be done. But what that has done is there's actually a huge cavity in this space here, because now all we have right here, at least in this unit, which this power unit is going to be what is in the kits. It's going to just be a DC-DC connector because we're just using
an external
200 watt power supply. A 200 watt at 24 volts, and that just has so much space so people can make what they want in there. So if you want, for example, to make an internal power supply, you absolutely can. So we're not going to be shipping with the internal power supply on this. However, it will be an optional upgrade in the future. We're going to make sure that the new base plate has everything you need to be able to add that. But that also opens it up for the community to be able to say, hey, USB spec already just recently, I think, went up to 240 watts.
Yeah, something huge,
like up to 24 volts. You can run this off a USB power delivery brick. So,
do I want to charge my laptop or run my printer? That's amazing.
We're really trying to focus on making this as customizable as possible for everyone. So, for example, if I flip this over, this has a USB port. That USB-C is specifically for the screen, so that's already going to be occupied. But we also have Ethernet port. We understand that not everyone wants to have their Clipper printers on Wi-Fi, especially if you're more cybersecurity focused. So, being able to put it on an Ethernet port and put it on a VLAN or something like that, being able to air gap it from the network, it's more possible with this, a lot easier to do. So, but the USB port allows you to use, say, just a thumbstick rather than an SD card. We do have an SD card with Clipper on it, so you could use that, or you could, send it over the internet because, of course, Clipper. But you can use a USB stick if you just don't have those available. Or you can hook up a webcam, or a nozzle can, or an additional fan for additional cooling. there's so much that you can do with this to make it your own.
Yeah.
And that's something that we're even now pushing for. For example, in the tool head here, this uses an IR sensor to do its Z-stop.
Right.
We already know, and we know from the community, IR sensors are not extremely reliable. They have deviancies that will just happen. We know. And that's one problem that we're trying to solve. We may not be able to fully solve it before we come to market, but what we're going to be doing instead is we're going to make sure there's pins on this CAN bus so that people can hook up whatever they want.
Oh, nice.
Camera's kind of off the distance.
Oh, what the hell?
Whoop. So we're going to make sure that there's pins on the board so that people can put on whatever probe they want, be it a clicky probe, a micro probe, anything. And that also allows the community to be able to help us kind of just improve upon the design.
Do I spot a different extruder as well on this one?
Yes.
Versus this one?
Thank you for reminding me about that. So this one uses just a direct extruder, not direct drive, but just this powers the extruder gears directly. We've gone ahead and upgraded it to an orbital extruder. So this will ship with an orbital extruder. So it gives more torque for the extrusions. We are now working on is, okay, we have a bunch of challenges with printing upside down that we're still figuring out. And I don't think we're gonna fully understand all the nuances of printing upside down until the community really gets their hands on this.
Yeah.
For example, when we're doing a complicated print, such as our little mini positron here, you can see my retraction settings weren't the best, so it's a little fuzzy, but we use supports for this. But how does supports work when you're printing like this? So instead of holding something up against gravity, you're pulling something up just like a resin printer.
Right, so you need a little bit more, you need the supports to hold a little bit more kind of...
Yeah, but at the same time, not really.
Yeah.
It's like if you look at a resin printer, they're thin. They're just holding it.
Yeah.
They're not holding it. So it's like, well, what changes in that dynamic? We don't actually know yet. We don't know how to customize a slicer and create new support material, so we don't actually know all the nuances of that specifically, but we are very excited to see the community get their hands on this and maybe experiment with different type of support material, support designs.
Yeah.
We like to call branch support or tree support, we like to call it root support,
right?
Because it's going down.
It looks like a root system, yeah.
And we found that to be obviously just as good as anything else. Normal supports work, which is kind of weird to think about, considering normal supports were designed not for upside down printing.
Yeah.
We just know there's gonna be a lot of research, a lot of investigation on how that changes things, and we're really excited for that.
Yeah.
And
it's really great to see that you've developed a platform that, as you say, has lots of potential and excitement and interest for the futurists. Like, the release of it will be almost the start of, let's see how far we can take this.
Yeah, and that's the idea. You know, we're trying to make the hardware as best as we can, and we're trying to tune it as best we can as well. This benchy is a good example of kind of what we're getting here. We understand that we definitely need a little bit more cooling, as well. Again, retraction settings on my unit alone definitely need to be improved, but we're aware of those things, and I want to make sure people are aware that we are aware. Like, we're not trying to say this is going to be a perfect printer. This is a different printer.
Yeah.
And even we're still doing our best to figure out all the little nuances, all the little ways that we need to improve. But we also know people really want to get this in their hands. So what we're going to be doing is we're going to be releasing it in batches, similar to the Milo. And we're going to keep working on it. We're not going to stop working on it. We're going to keep improving it, making it better, taking feedback from the community. Now, there's been debates of like, well, is it the community's responsibility to make a product good? We don't really think it is. It's not the community's responsibility. But Positron is a very small team. We can only do so much. And so we don't want to rely on the community. We're doing everything we can to make this the best thing that we possibly can. But we know that there's people out there that absolutely can make it even better, and we cannot wait to see what those people do. We're very excited to work with so many people on this because we know this could be a great project. It's very interesting building something to become like Voron when Voron already exists. I am able to copy their homework, and they're very happy to hear that. But it's very interesting to be like, well, Vorons at the beginning weren't perfect either. They took a lot of development to become where they are. and I'm hoping we can be similar and start building it up like that.
Excellent. Amazing. Well, thank you very much for talking to me.
Thank you.
It's a pleasure speaking to you.
Yeah, pleasure as well.
Hope you enjoy the rest of the show.
Thank you. You as
Cheers.
well.